everyone, and welcome to JSOA's latest webinar, New Space, the Constant Reinvention. I'm Catherine Guzinski, CEO of River Advisors, and I will be moderating today's discussion. Before we get started, I want to take a moment to thank the sponsor of today's webinar, Space Business Qualified, the innovative creators of new online training materials specifically designed for professionals in the space and satellite industry. As we navigate the complexities of our field, its access to high quality training resources is crucial. Space Business Qualified offers a range of courses that are incredibly beneficial for onboarding new staff, expanding the knowledge base of existing employees, and equipping everyone for increased responsibilities as our industry evolves. These courses not only enhance individual skills, but also contribute to a more competent and confident workforce, which is essential for driving our sector forward. I would encourage all of you to explore these resources available at spacebq.org. Now, allow me to introduce our panelists. We have Stuart Daughtridge, Vice President of Advanced Technology at Kratos, Jay Yass, Chief Corporate Development and Strategy Officer at OmniSpace, Ronald Vanderbreggen, Chief Commercial Officer at Rivada Space Networks, and Martin Erickson, Space Systems Manager at Ovzon. Now, as I mentioned, the topic of today's webinar is new space, and we're looking at the constant reinvention or the evolution of services that we've been seeing in recent years and continuing for the foreseeable future. The challenges we encounter spark reinvention in satellite technologies and services, and ultimately that leads to innovative approaches, innovative advancements in that technology to address those needs. We'll examine what's behind these transformations, technology convergence, opportunities, and ultimately what the future of connectivity looks like. But before we dive in, I want to remind our audience that you can submit questions using the Q&A function at any time during the webinar, and we'll address as many of those as we can. So to set the stage, I'd like to ask each of our panelists to share a little bit about their company's role in new space. So Martin, we'll start with you. Of course, Ovzon hit an exciting milestone this year. Could you tell us a little bit about the company's role in this space as well as those recent developments?
Yes, sure. So thank you. My name is Martin Erickson. As you said, I'm the Space Systems Manager at Ovzon. Ovzon is a Swedish-US public company founded in 2005. And we provide a unique SATCOM as a service to customers within defense, national security, and public safety. Our service is a complete end-to-end communication solution, including the satellite networks, mobile satellite terminals, gateway services, and dedicated 24/7 customer support. And we've been providing this capability for more than 10 years using leased satellite capacity from the major operators. But in January this year, we really did hit a huge milestone for us when we launched Ovzon 3, our first own satellite. A satellite specifically designed for performance, mobility, and resiliency, and it's been operational since July. Ovzon 3 is a GEO satellite. It's equipped with an all-steerable spot beam architecture, and it carries the Ovzon onboard processor, which is a reprogrammable payload that adds a host of new features to our offering. So we're a new satellite operator, maybe slightly less new spacey than some of the other panelists here. Yeah, that's us.
Excellent. Thank you, Martin. And now, Jay, OmniSpace is pushing us to redefine how we think about IoT. So if you don't mind, would you share a bit about the company and, of course, the latest developments for you as well?
Yes, thank you, Catherine. OmniSpace was founded in 2012 by veterans in the space industry. We were the former assets of ICO Global, which was ahead of its time in providing direct-to-device. So OmniSpace is focused on direct-to-device, providing a ubiquitous global connectivity to users everywhere around the globe. We're redefining what global mobile connectivity is by seamlessly working with mobile operators with our satellite connectivity. Over the last couple of years, we've been paving the way for the industry through developments of standards and technology and involvement with the mobile operators for this terrestrial satellite connectivity, which would bring direct-to-device IoT connected car use cases to the market. Omnispace is a founding member of the Mobile Satellite Services Association, promoting innovation for direct-to-device and IoT services on a global scale. Together with Viasat, TerreStar Solutions, Legato Networks, and Yahsats, this effort aims to deliver affordable, sustainable, and scalable connectivity to everyone across the globe.
Excellent. Thank you, Jay. And now, Ronald, Bravada sees itself as a little bit different from the rest of the field. So could you tell us a little bit about your company's role in the space and the latest news for you as well?
Well, maybe we're different, but we're using all the same components. We're just piecing them together a little bit different. But yes, you're right. Rivada Space Networks is going to launch what we have called the Outernet. It's a terrestrial approach towards space in that we are launching routers on top of satellites, and together they will form a network in space where through MPLS and some MEF compliancy, we're able to interconnect with all things terrestrial and carry that traffic through space as opposed to through all sorts of terrestrial infrastructure, be it the internet or fiber routes or anything else of that matter. So that comes with a couple of advantages, we believe, and have been verified and acknowledged also by our customer base, which is it's lower latency because through space bits travel faster than they do through a fiber optic cable. It's much more secure because if you are able to connect rooftops to other rooftops anywhere in the world, then bypassing anything terrestrial will just take out a lot of the threat surface that you typically have if you were to go through cables. Because it's not just the cable that can be dug up and cut, it's also the patch panels that are in between and riding third-party and other companies' networks and so on and so forth. So that's the view that we take. That's the business that we are in. That's the value proposition that we have. And we're looking to launch this in the next couple of years, hoping to be able to service enterprise customers who we believe have a great interest in anything that's faster and more secure, as well as government markets. In that case, again, we believe we're truly unique because we have this network approach, this terrestrial network approach to ultimately what is a very much a satellite business. So yeah, that's what we do.
Excellent. Thank you, Ronald. And finally, Stuart, Kratos has been making a big push toward virtualization and orchestration, and I understand you've been directly involved in the development of standards to advance this forward. So would you please tell us a bit about Kratos's role in new space and, of course, recent developments from your perspective as well?
Sure. So from a Kratos perspective, we do ground systems, everything from antennas back through the signal processing and routing to network management and command and control software. And several years ago, we just saw that the industry, to meet its future needs, are going to need to scale. And we saw that the only way that's going to happen is through virtualization and orchestration of the ground networks, similar to what the IT and telecom industries have already done. So we looked at virtualizing, how to virtualize the satellite ground systems by to allow them, the network functions and signal processing to run on generic x86 compute, and to allow that so that they could then be orchestrated and use, technologies like software-defined networking technologies. And so, our whole approach is moving the ground system from the legacy analog approach to a more of a digital ground future.
Excellent. Thank you, Stuart. So the first question I'd like for us to tackle is looking at the cause, the drivers, before we get to the end result. So when we look at many aspects within our industry ecosystem that have been changing in recent years, why reinvent? What's really driving these transformations? And Martin, if we could, I'll start with you, and we'll jump around a bit.
Sure. At the end of the day, it's really our customers' needs that drives all of our development and invention. At Ovzon, our goal is to provide solutions that allow our customers to achieve mission success. And the world is changing. The challenges of escalating geopolitical unrest, rapidly changing climate makes secure and mobile broadband communication more crucial than ever. And we see a renewed demand for sovereign satellite capacity and resilient communication networks that allow our customers to operate safely and efficiently, even in hostile and contested environments. And so this development has been going on for quite some time. But there has been a clear shift in recent years, as we see it, from focusing on throughput to prioritizing resilience. So that's what we see.
Thank you. And Stuart, your perspective on the drivers behind this.
Sure. So if you look at the beginning of New Space, what was really driven by the fact of lower cost launch and lower cost satellites. And so it was really about, now that we can get to space and we can produce a satellite and get it to space at a much lower cost, what can we do with it? And you saw a lot of proof of concepts, lots of different types of satellites, lots of startup companies. I think now we're at the point where, now that these proofs of concepts and demonstrations have happened, it's now about taking these technologies and business areas and turning them into, how do I turn this into a profitable business? And on the ground side, what we saw is, that's where we first saw the need for virtualization. So when the new space satellite companies came into play, and they could get to orbit, they could build their satellite way cheaper, they could get to orbit way cheaper. They needed a way lower cost, significantly lower cost ground system that could support that architecture. And that's really where virtualization was first applied in the satellite industry. We moved to software-based modems, and that allowed the ground as a service guys to really scale their businesses to support this industry. And that dramatically reduced the cost of the ground system, because now the antenna utilization and the ground system utilization for the ground as a service people was way higher, and therefore they could drop their costs significantly for the end customers. So that was the phase one. I think phase two is now, how do I scale this into a operational business with the scale that allows me to be profitable? We've seen that the satellite market, whether it be the EO market or SATCOM market, is a very elastic market, so that as we can drive down costs, the market expands. And so this is where you take, for the ground side, it's now taking this virtualization and orchestrating it and basically automating it so that you can drive down the costs even further. And that leads to greater scale, which again drives down the cost. And so, again, this is really just copying the models of the telco and IT industries. And also it allows us to plug into their supply chain and tool sets, which again are already built for scale type operations.
Mm-hmm. Thank you, Stuart. Jay, your thoughts on the drivers from your perspective?
I'm going to build on what Martin and Stuart said, being demand driven and scale, but we look at some of the tipping points. As a 3+ decade veteran in satellite industry, space has been reinventing itself from the different frequencies, from primarily C-band to KU to KA to, it's not about spectra, from big standard A terminals at 33 meter to small VSATs. So we're at an inflection point now because of the convergence of standards, the technology enabling, and the economics to scale, where you have the demand drivers on the phone, on the device, which is in the billions. And that's been the holy grail of satellite and making it affordable, is how do you get it to the billions? And the connectivity that could be provided direct to device, direct to vehicle, direct to IoT sensor is really enabled in a partnership with the mobile operators to scale to billions of devices, not 1 million or 10 million, but really billions.
Excellent. And Ronald, you get the last word, the drivers from your perspective.
Thank you. Well, many technologies have already been mentioned, so I'm not going to repeat that. So I'd like to take more of a 30,000 foot type approach here, if possible. And so that reminds me of this weekend. So my parents are still both alive. My father's 90. And as you have with parents, they ask questions like, what is it exactly that you do? Because I hear a lot about space, but I'm not really getting it. And so, and then when you try to find yourself explaining this to a 90-year-old, you're not going to talk about, all that technology. You need to take a different approach, but it's actually quite relevant because it kind of defines on how we perceive things and why we do what we do. So I said, look, if you were to compare the space industry with a children's daycare center, and you had like 20 kids there, and there was 30 toys, and life was good. We're talking the early 2000s here. You played with one toy, you gave it to another. Sure, there was, it's kids, right? There's some noise and there's people fighting with each other. But at the end of the day, it was fairly overseeable in that sense. And then I guess with SpaceX and coming in, dropping the launch prices to like 10% of what they are today, of what they were back in the day, it's like the equivalent of all of a sudden somebody coming in with 3 big boxes of Lego and, disturbing the whole place. And now you get an interesting dynamic. You get those that descend on the boxes, open them up, try to get their hands on as many pieces as they can, build the biggest structures and, really try to go big, fighting, other kids that try to do the same and all that. You got those that are on the sidelines and that wonder what the hell is happening. And maybe some of them want to get their parents called and be picked up because this is not fun anymore. And so lots of different dynamics then start to develop. And I think we also see that in our industry, right? I mean, there's people that thrive on, I wouldn't want to say the chaos, they go with what the customer is asking, they go with the flow, they make the most of it. So you typically see that in the reseller business where people start using Starlink because the customer is asking it, all sorts of, business lines are being developed, some fail, some work, there's some bankruptcies, there's some huge successes. There are those, like I said, that sit on the sideline. I think you see a lot of that in the manufacturing industry. You see that in the launch industry. There's a lot of what the hell just happened going on, and people are still trying to find their groove or redevelop a new one and that kind of thing. So in there, we are like, okay, so the world has clearly changed. There's a new dynamic in the industry. We're not going to go back to chalkboards and crayon. Lego is the name of the game right now. So we need to find our way through that, not build the massive infrastructures in the hopes for, that it will work. Consumer market, I think, is an example of that. We need to find those pieces that work for us, that we believe is able to not necessarily disrupt an industry, but tap into an industry that is currently not being served. So we're very specific about what we want: the lasers, the altitudes, the bus, there's a lot of things that are very specific to our needs, and we're building an infrastructure that is smaller. We're going about it in a very focused and targeted way to serve a specific customer need. And the customer need that we have here is enterprises and governments looking to connect, whether they're in the air or at sea or office buildings, in a way that has never been possible before with enhanced security and lower latency and a few other features like easy implementation, quick implementation, and I can go on and on. That is a different approach to what we have going on. I'm not passing judgment on one being better than the other. We're just doing it in a different way. We see boxes being brought in. We see new opportunities to quote unquote play with, but we're trying to do it in an extremely well thought out, targeted way, focusing on a specific high value service to a very specific market that has specific problems and has specific budgets set aside to solve those problems in a way that's not been able to be solved before. And that is what we're trying to do. So, that's our approach. So I don't think I talked satellite too much. But again, for us, it's more about the mechanics and the new opportunities that come with it than it is about specific events that require us to do specific things.
Sure. So, Ronald, that serves as a perfect segue to another question I have, which gets at, what has this evolution done, or how has this evolution enhanced connectivity and broader services to meet modern needs? So, if I could I want to make sure I get everyone's perspectives on this, but in a nutshell, that kind of a couple of key points. What are the real differences you see to customers, be they enterprise or end consumers, what have you, in terms of enhanced connectivity and services? That's the ultimate result from all of those factors, both conceptual and technological, that were talked about so far. What do you think the couple of points there are really the most impactful to the end customer?
Sure. So for us, as I mentioned before, security and low latency is a big thing. Being able to deploy networks quickly, which you cannot do in the terrestrial world, is a big thing. And what we particularly see nowadays, Catherine, is that with the events that we see going on in the world, I mean, we have the Middle East conflict, we have a Russian-Ukrainian war that doesn't seem to be coming to an end anytime soon. We have the tensions in the Southeast Asia with China and Taiwan. The level of interest on being able to secure traffic and operate sovereign networks that you can rest assured will keep your data safe is of increased importance. So what started out as we really believe this is something that enterprises need, that governments will appreciate, has really turned out to be something that is of increasing importance. So with all the changes that we've seen in the industry, it's been our belief that if we take satellites to the next level, in that it is not a bent pipe infrastructure connecting services to gateways, potentially with one or two lasers to extend that reach into gateways that are farther away, but really take it to a next level whereby we interconnect satellites as if they were routers, comes with enormous opportunities. And that seems to be confirmed by the customer uptake that we're seeing, because people do appreciate security. They do appreciate the ability to run large corporate applications across long distances, which now sometimes is impossible to do with even terrestrial infrastructure. So it's really for us about bringing terrestrial network technology in space and benefiting from the opportunities that come with that.
Outstanding. All right, Jay, I want to bring you into the conversation as well. So again, with those drivers in mind, those key points that are really impactful for the customer.
Thank you, Catherine. So the challenge, I believe, for this space industry is not creating demand, but fulfilling demand. And access to space, as Martin said, has been really been disrupted by SpaceX. There's affordable access to space now on a regular cadence. So that's been one item. But the other drivers, now that we have that, is fulfilling. How do you fulfill it? It's standard-based, it's scalability, and it's really affordability to really get everybody in, because the users themselves are able to create the demand on your device, on your vehicle, on your IoT sensor. It's how do you fulfill it seamlessly and globally that You don't care whether you're on a tower or a satellite, and it all works together. And again, that's the standards, the scalability that it could address the billions and make it affordable.
Thank you, Jay. And Stuart, I saw your head nodding when Jay mentioned standards. So from your perspective, with these drivers in mind, everything that's kind of pushing this evolution forward, how's that enhance connectivity and services to meet those needs, those modern needs from the customers?
Yeah, so if you look at our customers are the satellite operators, and for us, there's basically two types of markets. There's the Earth observation market and the SATCOM market. And if you look at the Earth observation market, it's really interesting that the sensors can produce massive amounts of data, but the big problem is how do you get that to the ground?
Exactly.
And so right now they limit what they can bring to the ground because the connectivity is just not there. So what you see is in the market now is there's a massive expansion going on in the ground as a service operator, both in the number of them and their scale. You see an expansion into the higher frequency bands to be able to download greater frequencies at greater amount of data per pass. You see inter-satellite links to LEO and GEO satellites to give basically on-demand access to downloading your sensor data. And you see optical to ground to give you a super high rate, all being worked on at this time. And I think the future for the EO market is a combination of all of these, where depending on your mission, you're going to pick which of those work best for you, and you're going to orchestrate across more than one of those to maximize your data downloads. In the SATCOM market, I think what we've learned from Starlink, it's really comes down to two things: cost and ease of use. And and so cost really comes with in many ways comes with scale, and scale comes with the use of standards, as Jay mentioned. And so we see if you look at how large IT networks work or telecom network work, they virtualize their infrastructure, they orchestrate their operations, they run on generic x86 compute. And I think you're going to see that come to the satellite industry, that same level of operations, and because it gives you scale and a lower cost point, and it also gives you access to larger supply chain. The other thing is, as I mentioned, Starlink has shown is that ease of use matters. If you look at the satellite industry today or the geo market traditionally, it was like ordering a T1 service back in the 90s. You order the service and you wait days to even months to be able to stand up and deploy that service. With Starlink, you go to Costco, you buy your terminal, you take it home, and you register it, and you're on. You turn it on, and in literally minutes, you have access. And that's because Starlink went with a 5G mobile, a 4G, 5G model for how to commission a service. And so I think you're going to see the industry move that way just because it creates an ease of use for the end customer that, now that it's available, why wouldn't you want to be able to stand up your service in minutes, being able to do it yourself versus having to, deploy, have your service provider deploy people to your house or to wherever it's needed to deploy that service. So I think those are the big areas where you're just seeing the market shift, and it's really a shift towards standards, and it's really a shift toward the terrestrial standards like 4G, 5G in the industry.
Excellent. Thank you, Stuart. And Martin, over to you to comment on how the services and connectivity enhancements have impacted the customer.
Yeah, thank you. So some really good points being made here. As Jay said, the need is already there. I think the modern need in large parts of the modern world, there's an expectation of being constantly connected. It applies to us as private persons. It applies to businesses. It applies to our customers at Ovzon. And the various new space initiatives have certainly moved that connectivity frontier, both geographically, but also from a device data rate and service perspective. And Starlink certainly has been leading that kind of wave. Now, when it comes to our customers, the needs are clear and they're distinct. We're, as I said earlier, maybe I'm a bit of the odd bird here. We're not targeting the millions or the billions, so the needs are very specific for our customers, and the focus is really on resilient solutions that ensure secure end-to-end communication and in all places and all conditions. And I think what Ronald said, I agree with that. That there are many ways to do this, and there are more interesting ways of doing it now than historically has been done. So our response to that is Ovzon 3, our satellite, which is a geosatellite, as I said, but it's purpose built for performance, mobility, and resiliency. It's a new platform. It's a pretty small satellite, not quite as small as we wanted. The going way back when we started this company, the goal was to really send up miniature geosatellites, and that was just not available. There weren't any solutions for that at the time. We're moving towards it. Ovzon 3 is a step on the way. But at the end of the day, we don't really care about the size of the satellite. The only size we care about is the terminal that the user is actually interfacing with and carrying. It's always the user in the first place. And then coming back to what Ronald said, Ovzon 3 hosts this Ovzon onboard processor, which is a reprogrammable software-defined payload, regenerative, that enables true mesh networking between these ultra-compact terminals that we also develop. And across the world, you can do single-hop communications, over a third of the world's surface, essentially. And I also agree with what Stuart is saying. I think with these various LEO initiatives, scale is such an important factor, and I think standardization, we're maybe going to get to that, but I think it's key. It's the only way to go when you're talking about scale.
Yeah, excellent question. I think we'll touch on standardization a little bit further. So we've gotten a couple of questions from the audience already, so I want to fold those in now and make sure that the folks listening are getting the answers to some of their questions. So folks in the audience, certainly if you have more, continue submitting those. And as I mentioned, we'll get to as many as we can during this session. So our first question, it's a bit of a long one, and we've got two parts here. So I'll read the entirety of it. We'll take it live. You should be able to see it, but we can certainly break this into two parts. So the question is, considering the inherent challenges of latency, operational frequency, and the cost of electronics and space-based direct-to-device solutions, which specific use cases do you see as having the most potential for scalable deployment? So I'd say that's part one of the questions. And Jay, I'll give you first crack at that, but I want to field the second part as well so folks can be thinking about it. The second part is, what critical factors, such as advancements in technology, regulatory changes, certainly standards, or cost efficiencies, do you believe are essential to address these obstacles and support widespread adoption? So Jay, if we could, let's go to you to tackle that question of, which specific use cases do you see as having the most potential for scalable deployment? And certainly we can get additional comments, as there may be some from the rest of the speakers.
Thank you, Catherine. So the use case that we see that's really driving the need for connectivity is the smartphone. And that's accomplished really through the standards. The 3GPP standard in release 17 starting has specific call out for NTN, non-terrestrial networks. And it's the first time that the standards body has incorporated a protocol for direct-to-device. So we see smartphone globally with the hundreds of mobile operators to have seamless connectivity to enhance their network coverage. But also we see other segments such as connected car for telematics and software updates and IoT sensors. And one big segment, which we believe will be using this direct-to-device, and I believe both Ronald and Martin talked about it, is the government military type of applications, very secure, very resilient type of communications. So those are, I believe, the use cases that are driving the demand for direct-to-device. And as I said before, and some of panelists said, it's the opportunity is how do you fulfill demand seamlessly and affordable?
Great point. I'll open this up to other speakers. Anyone else want to comment before we move on to additional questions? All right, well, then we'll go ahead, Stuart, please.
Okay, I'll just comment that I absolutely agree with what Jay said about direct device. It's probably the largest opportunity, related to scale, just because there's billions of devices, and there's a terrestrial you can't cover everywhere. So satellite has huge opportunities there. But I think it's really across the entire satellite spectrum, whether you're talking the EO market or any of the SATCOM markets, especially around anything related to mobility. I think there's just huge opportunities for the industry to grow, because as I said earlier, we've proven that the market is very elastic. So as we can drive down, if launch costs keep driving down, as satellite manufacturing costs keep driving down, ground system costs can keep being driven down, I think you're just going to see the market opportunities for satellite in every market area grow.
Mm-hmm. Absolutely. All right, great. Well, I would like to make sure we get through a few more questions. So if no burning comments at this moment in time, we'll move on to a few additional questions that we've received from the audience. I'll splice in one more, and then I want to talk a little bit more about convergence. So the next question is actually for you, Ronald. It's a specific question about how Rivada's in-space network compares to competitors. So they've specifically asked about Kuiper or Amazon's constellation. So would you mind fielding that one for us?
Yeah, as Chief Commercial Officer, I have no problem explaining why our product is better than anybody else's. So so that's music to my ears. But let me do that in a different way, because I just wanted to react on what Stuart said earlier. That gave me a pause, and in reacting on that, I'll answer that question as well. Which is, what we learned from Starlink is that two things are important. It is, I believe you said, Stuart, it is both ease of use and easy of install, and cost. And so I'll absolutely agree with the former part. And if there's anything I lay awake at night is, getting everything and all the pieces lined up such that it will indeed be exactly that is when we come to market. But I don't agree with the cost. As a matter of fact, I think we're doing ourselves in this industry a bit of a disfavor by continuing to focus on that. Now, let me give you an example. So it wasn't too long ago that I spoke with a big pharmaceutical, and we were talking about, why they would be interested in using this type of service that we're going to be putting out. And he said, I'm going to connect office buildings that I've already completely fibered up. I mean, I don't have any connectivity issues. Everything is fibered up. I got, abundance of bandwidth there. If I need to, I can light up another fiber. And so it's not that. I need it for different reasons. I need it to make sure that my research and development centers can talk to headquarters and vice versa, freely exchanging data that we deem to be critically important to the future of this company and to the success of our new products and so on and so forth. The price you put on security is, or rather, there is no price that you said I can put on security. I mean, if I have to go as a CIO, who we were talking with, to my board, and I get asked the question, how can you ensure? Then it's not about, how can you ensure security? Sorry. It's not about, it needs to be below X, because it's completely irrelevant. For me, it is about the value that you bring by setting it up in a way that is different from everything else. In our case, it was about the ability to offer a service that offers security on the lowest level of the OSI model, as I put it, right? I mean, we all talk about VPNs, so we take the V out of VPN, right? I mean, it's an RPN for that matter. It's a real private network. Which also then brings me to the question that was asked: why are we different? Everything else going on in space is an access network. We try to connect you to a nearest gateway, and then for the trunking and the backhaul and the long distance, we rely on fiber infrastructure or terrestrial networking in general. And so as long as we in our industry continue to, and the dog in the background is certainly agreeing with me, I hear. As long as we as an industry continue to focus on access and access alone, we're doing ourselves a disfavor. We have a unique infrastructure in space. We're paying a lot of money to put that up there, and to also start working on some of the trunking challenges that there are in the terrestrial world. We'd be doing ourselves a great favor. So while I agree that for Starlink, price is ultimately extremely important because they are an internet service provider, and we all know how that went in the late 90s. It's a race to the bottom, and I wish them good luck with that. It is dependent on the service that you offer as to whether price is the key decision factor or not. And we aim at those markets where it is not, because those markets exist and those problems are there and people have set budgets aside. So relative to all the others, yeah, I mean, we're not so much in the internet access business, we in the secure networking business, and that is a major differentiator to everything else out there.
Excellent. Thank you, Ronald. And I want to get another audience question here in, and then we'll turn our attention to convergence and talk a little more about standards. But Martin, this next question's for you. It was from the audience about specifically what bands does Ovzon 3 work in?
So Ovzon 3 is an all Ku-band satellite. We've chosen to work at Ku-band because we believe it's the best compromise between performance and availability. You know, everyone here knows, of course, but for the audience, attenuation that you get on a radio signal as it traverses the atmosphere is highly dependent on the frequency band, and higher frequencies are much more attenuated than lower frequencies. So that has a direct impact on the availability of the service, and we think Ku-band is the best compromise. That's what we've gone.
Excellent. Thank you, Martin. Now, I'd like to turn our attention to the topic of convergence. And certainly, convergence is a term that's been used in industry for far more than the last decade. So it can refer to many things, ranging from satellite-directed device to an orchestrated network of networks, among various other applications. And so appreciating that the definition can vary depending on your perspective. I'd like to understand how each of you view the opportunities presented by some of the technology convergence we're seeing. And Stuart, if I could, I'd like to start with you on this one.
Yeah, so, as I've already kind of mentioned, I think from a technology and standards point of view, you're definitely seeing a convergence of the satellite industry with the telecoms industry. And, as Jay mentioned, and, particularly 4G, 5G. And it just really makes sense because, that technology already has the scale, it already operates it cost effectively. It's already driving network efficiency. You get out of the standard, you get network efficiencies that the satellite industry's just never been able to achieve just because of the scale of the industry. So it massively simplifies the commissioning service once you move to these terrestrial standards. So all those things you get almost for free as you start to move towards as the satellite industry moves closer and closer to how the telco and terrestrial industry works and the wireless industry works. And I think that's one of the big technology convergences. And, those industries have all virtualized and orchestrated their infrastructure. And I think that's why you're seeing that move in satellite ground systems. And I think especially on the SATCOM side, but even in the EO side, basically what you're looking at is that the satellite communications is it being less special and becoming more just part of the overall telecoms network. And I think that's really good for the satellite industry. And I think you know, as Jay mentioned, 5G satellite got included in the 3G GPP specs for the first time. I think you'll see in 6G that satellite will be more of an integrated component of the network, which again, I think will create huge growth opportunity for the industry. So that's why I really think technology convergence, at least on the ground system, is driving the industry.
Excellent, thanks. And I'll open it up to anyone that would like to jump in on the question. We do have a few more from the audience that I'm hoping to get in before we close our session. But Jay, I think you had additional comments on this one.
Yes. Stuart said it perfectly. On standards have brought together the convergence of the mobile operator and the satellite into a seamless network. But I'll give a couple other convergent points, which I think are important, that the traditional GSO satellites and the NGSO, it's multi-orbit. And I believe that's the convergence that comes together. And Stuart's solution really helps drive that to be seamless with the telecom operators. And one other example of one of our MSSA, Mobile Satellite Services Association partners, Yahsat, the recent merger between Yahsat and Bayonet to create Space 42 brings AI and satellite together. And that's very powerful of bringing the AI component. One of the items that Martin talked about of getting the data down, there's not enough bandwidth and not enough spectrum in space to get the data down. But if you're doing AI processing on board, you could bring down those nuanced data that's really important and not just the fire hose of data. So see convergence in a number of different points there.
Excellent. Thank you, Jay. Martin, over to you.
Yeah, no, I think some good points being made here. The future may, just coming back to what Jay said, the future may very well be multi-orbit. There are some obvious applications, and clearly, system redundancy is one major aspect of that. 100% uptime may be possible. Today, I think we're still in a bit of a parallel universe, not in terms of particle physics, but in terms of supporting several parallel systems, supporting one customer. But I do see that development going on, and I do think that that's where we're moving. When it comes to standardization, I agree with most of what Stuart and Jay says here, but the telecom standardization has been very successful in creating a system really that selects for the best technical solutions. But the satellite segment has kind of come in as an add-on to that, or an afterthought. And so I don't think that's necessarily true anymore. And I think there's some work for us, for satellite operators to do to make sure that we really tie in and are integrated here in the best possible way.
Excellent. Thank you, Martin. And Ronald, over to you. Further comments on the opportunities created by convergence, if you have them.
Yeah, well, again, I mean, many things have already been said. So I would like to, and I may sound like a broken record, but we also need to take a look at the non-technical convergence, if you want. So telecom has been mentioned a couple of times. And so I think when we look at telcos, where typically satellite has always been taking, for lack of a better word, the back seat in providing that last mile access into far and forgotten places for which there really was no money anymore, so it had to be dirt cheap, to ultimately be one where we are a true partner, where we see their network strengths in terms of capacity and the ability to run massive applications and massive amounts of data across long distances via fiber optics and such, to match with some capabilities that we have in space beyond merely providing access. We're certainly trying to do that with the things that I talked about earlier. But I think we need to continue to have that discussion also on the in the area of the needs and the wants and desires of the end user. So it's not just the technology convergence where we talk about standardizations. It's also about working with telcos and cloud companies more closely, finding out what are the challenges that they're facing, and possibly rethink some of the assumptions that we've made in our industry, which typically nowadays revolve around providing access and getting and being low cost and setting up more gateways and all of that, into potentially doing something else and something different. We've certainly made an effort to do that. We found a huge opportunity there. And I like to believe there's more opportunities out there if we just better understand the needs and wants of our customers through the lens of the guys who really know a thing or two about data networking, and those are the telcos and the and the other network providers.
Great point, Ronald. So we have time for one more question from our audience, which really gets at security. And I know we talked about that from a couple of different perspectives. But the question is this: appreciating the drive to lower costs, the move towards software-defined networks, modems, et cetera. How does this impact the vulnerability or likelihood of failure of those satellite networks due to adversary interference? And I would say, there's kind of two aspects to this we could approach it from. Certainly, the question of interference is an interesting one as we have more commercial providers operating in shared space. And of course, we all want to scale. We need to do so sustainably. And addressing some of those sovereign needs with commercial networks. But the other way, certainly we could talk about it too, from that that convergence aspect, that orchestrated network of networks aspect. When you connect multiple networks, you are, of course, expanding the attack surface. So a couple of different directions to take this question. But what I'd like to do is direct this to Stuart to start, if I may, and then we can jump around from there.
Sure. So this is a great question. So it's really interesting. One of the things that has driven us to, the more virtualized ground system is the fact that the industry pivoted from broadcast to, IP transport. And one of the things, if we were still a broadcast industry, a virtualized ground system would buy you no value. You put up a carrier for 15 years, it never changes. There's no reason. But you move into IP transport. IP transport is very dynamic, and the network and the traffic patterns change both in the short term and the long term over a day. You get these you get traffic, repeatable traffic patterns, and they change over time. Over time, and so it's by being able to support that dynamic traffic capability. It gives you some options to deal with interference that you didn't have before. The other thing is with a virtual ground infrastructure, you can move your ground infrastructure around at the speed of your IT team versus having hardware distributed in only specific places. So if you have a purpose-built hardware modem, it is where it is. If you have a software modem that can run on any x86 platform that's connected to an antenna, that gives you a lot more options to change your ground system. The other thing I'll mention is that 4G and 5G networks are pretty resilient. If you're talking to a tower and that tower has a problem, you immediately switch over to some other cell, whatever the next best cell is. And so that technology being applied to satellite is a really powerful capability to give you some resiliency that's just not built into traditional TDMA or other traditional SATCOM capabilities, but it comes almost for free as soon as you move into a 4G, 5G type architecture. So I think the future gives you a lot more, just the size of network, it does expand your attack surface, but the size of network also gives you scale to deal with problems in ways you couldn't deal with them before.
Good point. Ronald, I saw you nodding your head, so I'll go to you next for comment.
No, I agree. I mean, I've been talking about security a lot, and I agree with you that there are many ways of looking at it. So I'll be brief this time. We offer the security, the whole VPN to RPN story that I gave earlier, and I heard the word attack surface. Reducing that goes a long way towards also being more and more secure. So inherently, Leos are inherently safe because they move around, very, very quickly. So there's that. And with in order to attack a constellation, you need to be on the ground and you need to know what you're doing. And if the constellation like we have is not gateway based, that takes away another area where you can try and hack your way into it, because I saw the hacking question there in the Q&As as well. So it's not just about offering the security to the end users, which is important and what we're to a large degree all about, but it's also the architecture that we have also comes with a highly reduced attack surface, like I explained. Being in Leo is inherently one of the reasons there. And as such, we have a service offering that we can demonstrate has a security, a very small attack surface relative to many other constellations out there that have far more ground dependency than we do. So yeah, that was why I was nodding yes. I'm not an expert in the field, as you can tell, but I enjoyed my discussions internally here with our security team, who whenever I talk to them, put me at ease to a large degree, because there's just a lot of security being embedded into the system.
That's a good point. It is always interesting the context in which we make our comparisons. I was on a session not long ago that said, well, how is satellite? They were comparing satellite to other modes of connectivity, and I said, well, if I'm a landlocked country with exclusively unfriendly neighbors, where do you think my fiber line goes? So, it's always the context in which you're comparing it to. But Martin, let's go over to you for further comment, and Jay, you'll get the last word.
Yeah, no, okay. So let me give the non-technical answer this time. It's this trade, right? It's kind of comparing with, are you going to develop your own specific software, your own specific solution that only you have, and you can confine it, you can make it very private, you can decrease the risk of being hacked that way, or you can use open source software that is available to everyone, but also the whole world is working on making it more resilient. So that's the trade.
It's an interesting trade space to manage. Jay, over to you for the final word.
And I'll take the different tact on spectrum security, meaning being in an interference-free environment. Satellite community has always been just that, a community where all the players abide by the rules, the levels, the ITU standards, the national band plan standards. And I see these days that there's less adherence to those standards. And I think that's a future topic, Catherine, that you have coming up with JSOA on sustainability. But the key resource is spectrum for the mobile operators and for the satellite operators. And being in that interference-free community is what makes us thrive, and again makes that cell phone work. When that one tower goes down, it switches to the next. That's because of the resilience of the spectrum.
Absolutely. Thank you, Jay. And as you mentioned, there is an upcoming webinar from JSOA that's tackling the issue of, well, I would argue scalability, which inherently implies sustainability, both in terms of physical space and assured access to spectrum use, which is in all of our interests. We can only scale up our operations and have commercially successful businesses if we have some level of visibility into the future. And JSOA has done wonderful work to advance that interest, both with its code of conduct and ongoing engagement with regulators to establish appropriate appropriate regulations and implementation. So with that, this brings us to the end of our discussion. Of course, any relevant questions we didn't address during the live program will be responded to in writing and posted next to the video on the JSOA website. You can watch the recording of this and previous webinars on the YouTube channel and on JSOA's website, gsoasatellite.com. The next webinar, Synergies in Space, Uniting Earth Observation and Communications for a Smarter Future, is planned for December 5th at the same time. So make sure you register for that. And finally, I want to thank our panelists very much for sharing their views, and thank you, audience, for the thoughtful questions, which made this a very engaging and enjoyable session to moderate for myself. Enjoy the rest of your morning, afternoon, or evening, wherever you may be, and we'll see you next time. Thanks, everyone.